Okay, now that we've done the lab dealing with acceleration, we want to get into the basics of how acceleration works and some of the types of problems we can solve with the acceleration formulas and concept. Acceleration is defined as any change in velocity. Anytime the velocity of an object changes, we define that as acceleration. In physics, we do not make a distinction specifically between acceleration and deceleration, the terms commonly used in the English language. We refer to any change in velocity as an acceleration, whether the object is speeding up or slowing down, or even changing direction. Remember, velocity is a vector, which means it contains both a magnitude, the speed, and a direction. So if you change the speed or change the direction, you are accelerating the object. The basic formula for acceleration is acceleration equals the change in velocity over the elapsed time. We will commonly rewrite this change in velocity, final velocity minus initial velocity, and generally our initial time is 0, so we write that way. You occasionally will also see this formula cross-multiplied and then add the initial to both sides. So the final velocity equals the initial velocity plus acceleration times time. So the two most common versions of this formula that you will use are that one and this one. They're the same formula, just rearranged. Because acceleration is any change in velocity, so any change in speed or direction, you can accelerate by speeding up, slowing down, or changing direction. So your car actually has 3 accelerators in the car: the gas pedal to speed up, the brake to slow down, or the steering wheel to change direction. Now, the direction of acceleration is something that's complicated for a lot of people. Acceleration has a direction just like velocity. It is a vector quantity. The typical units for acceleration are meters per second squared. You're dividing meters per second, velocity, by time, seconds. So meters per second, or meters per second squared. If you're accelerating in the same direction as the velocity, you will see the speed / velocity increase. One way to think about this, and we'll get into force in a later chapter, but if you were to push someone, you're going to cause them to change their velocity. You're going to apply a force, which causes an acceleration. If I push you in the same direction you are moving, you're going to go faster. Same concept here. If the acceleration and velocity are in the same direction, both positive or both negative, the speed or velocity will increase. If the acceleration is in the opposite direction as the velocity, here's a case where the speed or velocity will decrease. So think about if you wanted to stop someone. If they were coming towards you and you wanted to stop them, you'd push them in the opposite direction they're moving. You'd cause an acceleration in the opposite direction, which would cause them to slow down. So whenever you have an acceleration in the opposite direction of motion, the speed velocity decreases. So let's look at some example problems with acceleration. A roller coaster car rapidly picks up speed as it rolls down a slope. As it starts down the slope, its speed is 4 meters per second. 3 seconds later, at the bottom of the slope, its speed is 22 meters per second. What is its average acceleration? So let's write out the information we know. Meters per second, that's a speed or velocity. That's the starting speed or velocity, so we call it VI. The final speed or velocity is 22 meters per second. The time is 3 seconds, and we're looking for the acceleration. Next, I would write the formula. Acceleration equals v final minus v initial over t. So our acceleration in this case, now start plugging in our values, 22 minus 4 over 3. So 22 minus 4, 18, divided by 3, and we get an acceleration of 6 meters per second squared. Okay, and the next problem. Try this one on your own. and then by easiest way, press pause, and then come back and press play again, see if you got the right answer. So if a Ferrari with an initial velocity of 10 meters per second accelerates at a rate of 50 meters per second for 3 seconds, what is its final velocity? So here are given values: initial velocity, 10 meters per second, acceleration, 50 meters per second squared, time, 3 seconds, and we're looking for the final velocity. Our formula: acceleration equals v final minus v initial over t, or rearranged, v final equals v initial plus at. And that will actually be a little easier to solve, so let's use that one. V final equals 10 plus 50 times 3. So v final equals 10 plus 150. Final velocity here, 160 meters per second. Okay, here's another one for you to try. A skateboarder is moving north at a speed of 40 meters per second and comes to a stop in 5 seconds. What is the acceleration of the skateboarder? So press pause, try this on your own for a second, and then once you have an answer, press play again and see if you got it right. Okay, the data were given: the initial velocity, 40 meters per second. Now, here's where you don't see a number, but you have a piece of data. Stop. We know stop is a final velocity of 0. So sometimes you'll see a word in a problem that is actually telling you a piece of data. Stop, at rest are two very common examples of that, meaning 0 velocity. The time is 5 seconds. We're looking for the acceleration. Acceleration equals v final minus v initial over t. So acceleration equals 0 minus 40 over 5. So our acceleration is negative 40 divided by 5. So our acceleration of negative 8 meters per second squared. Remember, in this case, our final velocity, our final acceleration, is negative. And we said that anytime the acceleration and velocity are in opposite direction, the object will be slowing down. Here the object is slowing down from 40 to rest, so it should have a negative acceleration. Here's another problem. Give this one a try. Okay, our starting information: initial velocity of 20. And acceleration, it is slowing down, so we know the acceleration must be negative. We want to figure out when it comes to a stop, so the final velocity would be 0. And we're looking for the time. Here it's probably easiest to use the VF equals VI plus AT. So 0 equals 20 plus negative 4t. So 4t, add 4t to both sides, equals 20. T equals 5 seconds. So here we've had a number of example problems dealing with the concept of acceleration. Direction of acceleration is very important. We need to understand the basic concept.